Start recording. Hello everyone and welcome to Handmade Hero Show, where we code a complete game live on Twitch. Now, we are at the precipice. We are about to like soar off the precipice of having some good profile inspection code so we can see where our time is being spent. I'm fairly excited about it. We just barely got things working yesterday's stream, but we had some bugs and we didn't have time to really look into them at the end of last night's stream. So today, I think will be the day that we finally get to see this stuff sort of come to fruition a little bit. And we get to start working on some new stuff that I think will be a lot of fun, like putting in some interface stuff so that we can quickly navigate around and like drill down on the perf stuff. And that's going to be kind of fun. That's sort of a new thing. I'll break from the actual debug data collection now that that's working properly. So if we go ahead and get started on that, I think there's not much to say about it. It's just us debugging our stuff from yesterday. Today is day 186, so if you unpack day 185 source code into directory, that's what I'm starting with. So if you pre-order the game on handmadehero.org, that's the source code that you want to work with. Now, if I remember correctly, we sort of had some stuff drawing, but it wasn't correct. So we knew there was some kind of problem with what we had written, but we didn't have any time to really see what was actually going on. Like, it was definitely not correct, but we weren't sure what was incorrect about it. And so, like, for example, on here you can kind of see we've got sort of something that kind of starts to look like a correct series of things, but then it rapidly scrolls off, and then we have, essentially these should be all frames that are being displayed in here. Essentially, we've got just one, it looks like, frame at the beginning, and then nothing else. So to me, that suggests that we've just got a bug in how we're binning things into frames or something like this. And so that instead of having a full screen's worth of frames, we're not properly accounting for that. And we're getting just like one bucket with nothing in it, or some weird situation is happening. So we need to kind of dive in and figure out what's going on there so we can figure out what's going wrong and solve it, right? So let's go ahead and take a look at what we've got and see what the problem is. So let's just take a minute to refresh our memories of what's going on here. And I'm going to sort of take a look into the code. So the way that we have things structured is we maintain sort of a little collation thing here. Every frame we come through and we create a new sort of memory scratch pad, and we build up this information, which is a set of frames that have in them, up here, right, would have in them sort of the beginning and ending clock for that frame, and then a series of regions, and the regions are essentially time spans where something was happening. So that's all we're trying to accomplish right now, and we sort of started to see that happening on the screen. But we should be seeing a full screen's worth of frames with little colored regions, and we're not seeing that. So the first question I have, is the debug frame stuff happening properly? Are we actually seeing those debug frames getting built up properly? And so what I'd like to do is take a look at that and find out what's happening in there. So there's a couple of different things that I think could be happening in there one way or the other. So the first thing that I was thinking is, well, we have potentially more debug frames than we have event arrays. Like, I don't actually know how that stuff is shaking out at the moment. So I'd like to do something where I just look at what the frame count actually is. So I want to just, how many frames does it think it got? So I'm going to just let this thing run a bit. You can even see it's kind of like does this weird thing when it starts up where it's kind of sitting there, right? And like these frames are not getting pushed off. So these are like presumably the initial frames. And then it looks like once we hit a certain number, they start to scroll by, right? So it seems like the frames are kind of moving backwards the way they were expected. So the weird part is that nothing seems to be moving in from the left, from the right. We should be seeing frames of data, and instead we're just getting nothing. It doesn't really make any sense. And furthermore, I don't know what that's doing there, because how is that thing varying when we don't see those frames coming at and moving this way? So I want to kind of start to look and see, first of all, how many frames do we think we have? and some stuff like this. I just want to get a feeling for what might be going wrong there. Okay. So here we go. Let's go ahead and just stop. Basically, right after that collation has happened, I'm going to take a look at the debug state. And here we go. So we think we have 63 frames. And that seems like pretty much exactly the number I would have expected to see. And if we take a look at those frames, well, we can see kind of right off the bat what the problem is. We're really not getting any regions in there. And I feel like that's probably, no matter what the case, I don't feel like there should probably only be 2 regions. That seems really unusual. And here we go. We've got 2 regions in one and then zeros in the rest. So it seems pretty clear that we just have a pretty fundamental basic bug in there. Because that just doesn't make any sense. There's no way that could actually be what's happening, I don't think, with the data we're collating. So I'm going to go ahead and take a look. We probably just have some kind of a basic problem with the way that we're collating that's, you know, yielding this problem. So when we come through here, we are making sort of an array of frames to store our frames, and we're saying that we're just going to make enough that we know that we won't overflow it. We initialize all of our scale stuff, and we decided not to play with frame bar scale yet, so we're just kind of setting that at a constant value so that that won't change as the graph progresses. So then we come through our events, and every time, I guess, we go through our event array. You know, I should probably pre-warm this up so that we're at the point where it's buggy, right? Because we're getting some actual data here, so that's actually looks kind of valid at the moment. So let's let it kind of scroll off, so that now that we know we're in a just known totally bad position, now let's kind of come through and see what happens there. So our global debug table contains all of the data for the debugging, right? It contains all of the events that have been stored up. So if I take a look at the event count array, that is all of the events that are happening here. And you can see what the counts are. The counts are massive. There's plenty of events in there. So it seems unlikely that we aren't getting at least a few top-level events everywhere. And so looking at that, it's like, okay, it doesn't look like the problem is that like we're not recording any events, because it looks like we're definitely recording a ton of events. So that's fine. So if we grab out some of these events here, we can take a look at how they're working. We get a frame marker as the very first thing. That seems fine. So we're going to assign a current frame to that, and here it is. We're then going to assign sort of like the clocks to it. There's the beginning clock. The end clock hasn't been recorded yet. The region count's going to be 0, and it's going to have some kind of a nominal region count there. Then we come through and we look. We are on frame 0. We take a look at what the thread is that we're currently on. That's thread 5408. That's the ID. And what we should see in the debug state is now there should be one thread in the table of threads. There it is. It's assigned a lane index, which is what we want. It remembers the ID. It has no open block at the moment, because that's exactly what we would expect. We take a look. It's a begin block. That's what we would think, because you know it's the start of the frame. We're going to open up that block. And of course, there isn't anything on the free store, because why would there be? We haven't allocated anything yet. So we go ahead and allocate a new debug block. We put which frame it's on here. We take the opening event there and record it. It's this one that's causing us to happen. We remember what the parent block was, and then we set, which of course is nothing yet, we set it to be us from now on, so anyone underneath us is going to be inside this block. And then we, continue on. And so now anyone under here, oh, well, there's the end block. So it looks like there was no timings inside that block. In fact, I wonder if we could even see, if we could actually see in there what the actual, well, I guess we don't have a way. I should have checked up here. We could have seen which block was being opened. But anyway, no big deal. So we come through here and we say, all right, we have a matching begin and end block. That was what this does. It ensures that we're matching. When it matches, we see whether it's on the same frame. It was. We see whether or not the open block had a parent, because we're just taking the top level ones, and we find that it did not. So we just say, okay, let's record that into the current lane for this thread, and using the sort of the clock base that we would expect. So there's that begin clock of the frame. We're just going to remember the timing of this relative to that begin clock. So we do that there, and we say, okay, we're good to go. All right, so at that point, now what we want to do is we want to mark this block as being free. So we go ahead and we dump it onto the free list. Wait a minute, what's going on here? First open block, next free, equals debug state, first free block, first open block. Oh, that's just because this is the thing. I probably should have used matching block there. That's a little odd to look at. But anyway, so we take whatever the current free list is, we stick it onto us. We then set whatever the free list head pointer is, and we set it pointing to us. We then make sure that we move one up, the parent, so it should set the first open block for the thread to be equal to 0, which it does. And then we continue. So now we're going to see presumably another begin block. There it is. And of course, this debug block already has a, there's already something on the free store, so we just use the one that we'd already allocated. We set all of its values, so those all now get set properly as far as I can tell. And let's just double check that, I guess. Do we have a good debug block view here? Debug block. Let's move this down a little bit. So there it is set up. So we set the parent equal to the parent should be. We cleared the next free, and we set the two values to what they should be. So that's all good as well. We can take a look at what opening event this is as well. The source should be in here. Do we ever grab the source? We never grab the source, unfortunately. Oh well. Well, here it is. So this is input processing. So again, exactly what we would think we would see. So there we go. Here we are for the end block for input processing. And again, it works pretty much exactly as I would have expected it to. Right? And I don't, again, I'm not seeing any real problems yet. I'm not seeing anything particularly odd happening here. It looks pretty good. So now let's see what happens when we get to something. I assume we're going to get to the game first that has children. So let's see, game update. So now this is going to have a bunch of children. So this is the first time we're going to see a bunch of children here. We create the open block, and now we're going to probably see another begin block, right? For the first time we're seeing that. So what I'm going to do here is I'm just going to set a breakpoint for the next time that we hit an end block. And I'm also going to make sure we don't see something like a frame marker before then, just to make sure everything's relatively kosher there. So there we go. We're hitting an end block, and presumably that's going to line up, right? And it's going to remove it. It does, and so that's fine. We then come back around. And now I'm going to check to see when the next time we hit one of these is, right? So the next time we close something that we're actually going to record. And again, I'm going to just set a breakpoint to make sure up there that we okay. So it looks like we have something bogus happening in terms of our block pairing or something like this, right? Because we should not have been able to get to the new frame without having closed the game update block. Let me see, Win32 Handmade. Because if you take a look at, oops, game update, well, update game, timer block, begin block. Okay, begin block input processing. Let's take a look at end block. So we saw that one. We've got begin block game update. So then we've got end block game update. So we should have hit this, and that should have closed out at the top level. It didn't, right? We did not see that happen. And so what I'd like to do is I'd like to figure out some way of stopping us at the point where that happened. And so I'm trying to think of the best way to do that. So inside the debug code, like I want to see what happened on that frame where, you know, when we get to this, what is the circumstance that causes this to fail, right? So in order to do that, inside here somewhere, when we look at this stuff, I mean, one thing I could do, right, is I could complain here about it, I suppose. Do we have any blocks? I guess on other threads we do, so it's hard to say. I'm trying to think of how I want to approach this. So on any given thread, we're always looking at the first open block on the thread. So we know that they close in, open and close in order. So I guess what I'd like to do is come in here and say, well, when we get to the end block event, I would like to know, for this guy here, I would like to know if it's this one, if it's this particular end block event. And so I know that the game update will appear as a string, right? So what I could do is I could just full on do some kind of a string compare here, where I just say if the source block name and this equals 0, then that's the one I'm looking for, right? Something like this, which is just, again, totally random. I could just straight up do that. Now, we haven't written a string compare. We could use the one in the C runtime library, but they're so easy, we might as well just write one ourselves. Again, I don't know, really, we don't have a utility function area yet, but we can just throw one in here. They're that simple. You know, it would be something trivial like, I just want, I want some way of returning, you know, a signed difference value that's going to be positive or negative. In fact, I guess I could even just do a Boolean one for now. So do strings are equal, and just have a, and I assume we haven't already done that. Strings are equal. Maybe we have. Oh, we already did it. Never mind. Never mind. Strings are equal, identifier not found. Oh. It was finding the one that I already wrote. Okay, so we didn't do it. So here we go. We pass two things to our strings are equal. We just want to know if these two things are the same or not. And we're going to return a value that's like true or false based on whether or not they match, right? So all I really need to do here is just do something like, you know, while a equals, you know, while star a plus plus equals star b plus plus or something like this. And we don't want to kind of go over. So we probably want to do while star a and star b. And maybe I won't do that in here just to make it a little clearer what's going on. I'll put it inside, right? So while everything is valid and the two things are equal, we can advance one letter. You know, just a really very stupid string compare. So while we're not at the null terminator of A, we're not at the null terminator of B, and A equals B for the characters, whatever they're pointing to, we'll advance them by one character. And then if at any time these guys are not equal to each other, it would stop the loop. The criteria for knowing whether or not they were equal at the end should be that they both hit their null terminator. You know, so the result is just going to be that star A equals star B, you know, and star A equals 0, which is like, you know, or you could alternately think it this way. If both of them are now pointing to null, then we've reached the end of the string. If they aren't, then then we know there was a difference. So now I've got a string compare, and I can do this. So if strings are equal to, then we'll stop, and I'll just put a thing in here so I can set a breakpoint on it. All right, so if we are to run it again, off we go. There we are. And so as we sort of move forward, oh, well, that's particularly odd. Access violation writing location 0. So we had more in that one than we normally do, which is a little weird. I wonder why. It doesn't really matter, I suppose, for now, but it's weird that that didn't happen in previous runs. You'd think we'd have roughly the same number of debug events. So that was a little odd, to say the least, but no big deal. Not what I want to look at the moment, to say the least. Okay, so this is kind of settled down to its bogus state. So now I want to kind of look at what is the reason why that this game update never actually gets cleared. So this first time through, we should be looking at the open block, and oh wait, no, sorry, that's the end block. Never mind. Well, let's try that one more time. All right, so here we are on the end block for game update. We come through here. What's in the thread? Let's find out. And so our thread first open block, there it is. So that's valid. We then take a look at the stuff here, what the opening event was, and let's take a look at these guys. So we've got the opening event, and we've got our event. Okay, so they're both on the same thread, which is what we expect because that's, how things are being recorded. And then we have a debug record index that does not match. In fact, a translation unit does not match either. So these are two totally different events here. So I'm not sure how that's actually happening. That's obviously what the problem is. So if we take a look at debug for our thread, if we take a look at our first open block, how far up does it go, right? It's got 1 parent, 2 parents, 3 parents, 4 parents. So it's super deep, right? Look at this. That's crazy how deep down it goes. It feels to me like there's like an unclosed block, right? It feels like something in there isn't closed properly. And I'm not sure, why that would be. But look at this. Look at how many there are here, right? So I feel like the easiest thing to do would be to just look at what are these opening events that are never getting closed. And in fact, if you look, these opening events are all the same event. They're all the zero event. So there's some, I think we just have a bug in the record recording, right? That's causing that to get pushed on there. In translation unit 0, the first debug record index. And so I guess what I'll do is I'll just say, well, which one was that? If I take a look at global debug table, I should be able to look at this records here. Global debug table, records 0, 0 should tell me, I would think, who that was. Global debug table era. And So let's see. This is who it was. It is handmade render group.cpp. It's draw rectangle, line number 39. So let's take a look. So our timed function does not seem to be closing itself. So maybe we just, when we did our sort of our porting of this stuff, maybe we just didn't do it right. Maybe end block with this counter is somehow not doing what it should be doing. I don't know. Because that should be pretty straightforward. So let's see. Timed underscore function is going to call timed block. It's going to call it with these parameters, right? And we know that that's working because we saw those values in there. So we know that this part is working. We know that we're hitting the begin block. And the begin block itself is, I guess, doing this, right? So it's getting one of these debug records, it's filling out the file name, which we know is happening properly, then it's doing a record debug event of the counter, whichever counter we're on, and it's using the begin block tag. So we then do an end block with the counter, and that's doing a record debug event of the counter and the debug event end block. And so that feels like that should be correct. I don't see why we would be having a problem there, because here is where we store that counter and it right into this integer. We use it in both places, passing it through the macro. So it seems like that should be fine. I guess what I'd like to do is just take a look at draw rectangle so I can see what's going on. So here we are in draw rectangle. And here we are in timed block. So let's go ahead in there. Global debug table. And let's see here. The counter is 0, which is what we'd expect. Begin block is going into record debug event. That is exactly what we would expect to see. We're getting an event index out of the pool. We are, and now we hit timed block again, but for probably somebody else, I would think. Although is draw rectangle again? I'm not sure exactly what happened there. Could be a different thread. I'm not sure. Let's find out. 3780. Okay, so we get our core index. Here we come on counter init. So again, I guess this is a different one of them. There's the translation unit. Or that could actually just be jumping around, because that may actually just be because this might be an optimized function here. I'm not sure. Anyway, I don't think we put it in the optimized section though. So all right, we got our translation unit, so we got everything recorded, and that's all good. And that feels correct. Nothing in there looked weird to me. Here we go. Yeah, is this, how come this code appears to be optimized? Oh, you know what? Oh. You know, it probably is optimized because it's getting called from inside something that was compiled with optimizations on, I'm guessing? Or did we compile with optimizations on? We're not compiling with optimizations on, are we? Yeah, OD. And is optimized, handmade optimized.cpp. It's only this one function, so I don't understand, why does this appear to have been compiled with optimizations on? It's jumping all around. But it could just be, well, it could just be that, yeah, so it's just another thread. There's another thread that's in draw rectangle. So that's all we're seeing. It's not jumping around, it's just multiple threads. So that's fine. Just wanted to make sure. You can barely see that little guy on this monitor, but I don't know if you could see that. Do you see that right there? That little thing? That's the little marker that says that the actual thread you're looking at switched when between steps. So that's going to go ahead and do the fill. So I'm just going to go ahead and hop down here. I want to double check that I'm before the part where things would be closed out. So you can see there's the call, the ending call. So I'm going to let's hop down there. There we go. And step in here. Here we go into end block. So we come down, recording 0. Thread ID is 255. Oh wait, but that's in the guy who doesn't. I don't know why it's hopping around quite so much. 3780. So it's properly recording an end event there, right? So I'm not sure what the problem is. It seems like it's fine. It seems like that should be fine to me. You know? We have multiple threads that are hitting that function, but I don't feel like that should be causing us a problem because we're expecting it. Maybe our code for dealing with the multiple threads stuff is wrong. So I guess let's take a quick look at that and see. So what I'm going to do is I'm going to do the exact same thing I just did, only instead of looking at the end block, I'm going to look at both. So I'm going to just go ahead and check anytime we have draw rectangle. I wanna know about it, right? So I could actually just go ahead and do it here. So before we start parsing anything, I want to see when we get to that. Okay. So in the debug code, I'm going to set a breakpoint there. So I'm going to let this guy go for a little bit, again, just to make sure that we're past any like frames that may happen to work by luck, and that I know that we're into frames that are definitely busted. And then I'm going to go ahead and set the breakpoint. So here we go on the entry for this guy, the first entry. So there is amusingly, draw rectangle, the place that's probably being called mostly is in the debug code. So we're probably causing this bug by drawing rectangles in the debug code itself, which is kind of hilarious. But anyway, so here we go. We have an opening one. So we'll go ahead and take a look at that. So there's thread 6040, opened one, and now thread 6040 opened one again or closed one? So this is just weird, right? Thread 6040 should not be able to open this many draw rectangles without closing them, right? That just should not be possible. That is not something that should be possible. Are we reading past the end of the array here? Well, it's got a valid thread ID set, so I don't know. Event redirect is 32. Event count. Invalid array is +1, so that's fine. So we're looping through those guys. I say. So I guess I'll try one more thing, which is I will go ahead and set inside inside my render group stuff here where we call that draw rectangle. Here's where we're doing that. What I want to do is I want to look and see when we get here. I want to look at the global debug table, and I want to just get an opinion about where it's writing to, and I want to look at it. So I want to see what we're actually writing to it and when. Now that's controlled by this guy. And so the top is the event array index. So if I shift this down by 32, I can see which it is. And of course, I guess I want to wait again. I want to wait till we get to known bad behavior, because these actually look kind of correct, right? All right. So now let me go back there, set that breakpoint. So here's our event array index, you know, and then I'm going to do the same thing. Oops. I'm going to do the same thing to find out what the event index is that we do in the actual code. So 2722 is the code, is the location. So I'm going to look at global debug table. And I want to look at global debug table, the events for array 8, and I want to see the 2762th of them, right? I guess I should do it probably like this. Okay. And I would like to see potentially more than just one of those. But yeah. And so if also let's take a look at, while we're at it, let's just see what the global debug table event count is for array 8 at the moment. Yeah, so that's bogus at the moment, but that's okay because it gets set at the end. So that's fine. We can double check that that actually works properly, I suppose, a little bit later. So if we take a look at this, we're about to write into this guy here. So there's us writing into it. We're trying to. We wrote in 5264. There's one there. I'm going to look. I want to look at a few more of these. Can I look at like 16 of these potentially? I guess not. There we go. So you can kind of see here is what we got. I'm going to keep looking through here at these guys. So, you know, I mean, if you just look at what's writing in there, I'm not seeing that pattern that we see when we actually go to collate it. There's 5264. There's 6116. There's 1628. They're all different thread IDs that are coming through here. 5452. So where's the first one that, there's 616. So where the first time we see that again is here. So let's see what happens here. So 6116, what are we on? We're on 2769. So 2769, 62. So we have written past here. So, but that does look like we wrote 2 in without closing it. Yeah? So I don't understand, like, how did that happen? How indeed? That's pretty troubling to me, because that means we're just writing bogus data in here. Like with this, like the actual debug log is wrong. So our collation routine isn't really wrong. This routine is, or who knows which routine, is actually writing the stuff out improperly. And I don't know why. So again, all we're doing is calling that end block here. So I'm not sure how it's getting 2 opens without the close. it doesn't really make much sense. When we do record debug event, we're doing an atomic add, and so it feels like we should not have that problem. Now, I wonder if, I guess there could be a thing where it's optimizing it or not reloading it, although the atomic add is supposed to always treat it as volatile. So that seems impossible, basically, because we're going through a known compiler path there. We have 20 minutes left on the clock, so we actually have quite a bit past this. So this is a bit of a puzzler, right? This is a bit odd. This is all looks relatively innocent in terms of how we're addressing this stuff. So I'll go ahead and step in here one more time and see what else I can see. So the first frames, it seemed like it worked more properly too, right? So let's take a look here. Here are our here are our values. So we're at array 0. Our event index, that does not look like a proper event index. Does that look like a proper event index to you? That just looks totally bogus. Maybe that's because by the time we got to draw a rectangle, that actually was the case. But it does seem a bit odd, right? Possible, but a bit odd. I'm going to make sure that's correct as well. So let's step in here, game, update, and render. All right, so when we step in here, our global debug table, event array index, and event array index, event index here are both 0. That's what we would expect. I'm going to run through one more time to the second frame, and then I'm going to see what happens. So 6118 is the current amount. That seems like it could be plausible given that there are other threads that are running, and we're on array index 1. That all seems relatively plausible. I could believe it. So this frame is not a known bad frame necessarily, but now I want to see, I'm just going to go in here and take a look at this time function. I want to see what actually happens here. So inside the timed function, I'm going to watch what it writes. I'm just going to use, again, this ability to sort of view what it ends up writing out to the stream. So here we go. So we should see some writes here to this location. There we go. Wow. Look at that. It's just pure nonsense in here. Like here you've got 164 ending, 164 ending again. Here's 164 ending again. Right? Because the values for those guys is 0, 1, 2. So a 2 means it was an end block. That's just full banana cakes. There's like no way that that should be happening. So I'm not sure what to make of it. And I mean, look at all that. That's purely crazy. So I guess one thing is our get thread ID function busted? You know, like did we implement that wrong, right? Is this guy wrong? And we could test that, right? We can try to figure out a way to test that. Since we would be, I mean, trying to think of what the easiest way to do that would be. We could probably try to do something here where we used thread local storage or something like this directly. I guess. I don't really know. We could do something like that, but you know, it's possible that this thing is just reading a bogus value out. And I'm not sure what else I could do. What else I could do to test that? we don't have the ability to call windows directly in here in this part of the code. So there's no way for me to call actual get thread ID. I guess we could start linking with kernel in this DLL. But like I can't do this, you know, at the moment anyway. That's not a known thing. So I don't know. On the other hand, those look like valid thread things. And so I guess I could also, you know what I could do too? I can test it where I do create thread. So here's create thread. Create thread immediately calls thread proc with the new thread. What I can do here is I can say, oh, give me the thread ID, you know, and then assert that the test thread ID equals get current thread ID, right? So that I'm sure that Windows and I are getting the same value when we do a thread ID test. We'll just try that, just to see. And so it looks like that's working just fine. So it seems to think the thread ID is the same. So we've got something stupid going on, but we just don't know what it is, right? Something stupid is happening, but we don't know what it is. And I guess, you know, it seems like it happens under stress, meaning when you have a function that multiple threads are calling at the same time. Apparently, this seems to be a problem. So with the way this is working, perhaps something about how this atomic is being accessed, perhaps something about the way that I'm doing it is not proper, like something is getting lost. I'm not entirely sure, but I'll double check. Atomic add U64. We are marking it as volatile, right? I don't know if one of these casts is maybe a bad idea, but I don't think so. This is, I suppose, a volatile as well, but that shouldn't have any. That should really just. That should not have any effect on anything that I can think of at all. This is a stumper. It's a bit of a stumper. And it's especially stumpy because you can see that it happens correctly for a little while. Like this is exactly what we would expect to see for the most part, right? That is like those are, well, we'll get them back here. Those are our debug, asynchronous debug threads spinning up, doing a bunch of rendering, and then coming back, I would assume, right? So this is a totally plausible visual picture. So the question is just what happens? Why do things go sour? And why does it start to record these totally bogus things? I obviously have some kind of a bug with how those things are getting written out, but I don't know what it is. I suppose I could look at the assembly, might maybe illuminate something, but that's sort of presuming that there's something subtle happening that's wrong, whereas I'm kind of expecting it must be something blatant that we're doing wrong, like something that's just flat out totally wrong, you know? Because in order for it to write out such ridiculous data, it has to either be missing a particular piece of debug information, or it must like get the event type wrong in some way. And I'm totally not seeing it. Record, oops. Record debug event. And I guess one thing we could do is we could sort of take this part out of the equation a little bit too, just for fun. We could do something like this. Since I don't have any immediate idea what the problem is. I could do something like count begin block, draw a rectangle, end block, draw a rectangle. And now it would be going through, it wouldn't be using the constructor-destructor paired one, and it would be using the more explicit path. So it's still incorrect, as far as I can tell, which is good. That would be even scarier if somehow that wasn't the case. But now when I set a breakpoint here, I can look a little bit more explicitly at when it's doing what, right? Okay. So let me set a breakpoint there as well. So you can see these guys kind of coming down through here, right? It's a whole bunch of people hitting this function at the same time. They're doing whatever rectangle filling fun they want to do. And then eventually, I don't know why when I hit run, it still shows me things from other threads. But then when we get down to end block for draw a rectangle, I want to see what that records. So we're on event array 3 at the moment, and we're on 2271 is the event. And so let's see what happens here. If I step into this guy, it's going to write to 2272, which should be like that guy. Oh, sorry, 2271 it will write to. That's the next value. So it writes in there. I don't know why the thread ID... Oh, it didn't update, just did a change there. So it's thread ID 68. What's the event type? Event type is end block. That's what I would expect to see. So that's good, right? Everything is still happening the way I want it to. So that's all good. And then, let's see. Now we come through here. Somebody else has done their increment, it looks like. I want you to keep going, man. So we're on 2774 now. So it ended it for 2 of the different threads here. Here we go, 1600. Yeah, I don't know. I'm gonna have to come up with a more creative way to debug this because I don't see anything obviously weird happening here. I don't see it. But by the time we sort of get out to here, it's definitely having this weird thing where it's having a, I don't know if it's a race condition or a write problem or what, but it's eluding me at the moment. Really just to the point of where I'm not even sure, I don't have a really good hypothesis for, like, usually I can think of like, oh, here's something I suspect could be happening, let's go investigate it. I don't really have one of those. So I'm gonna pause. Here's the thing you can do. I don't normally do this, but I'm gonna do it anyway. You can kind of see it's crazy. All of these people hit draw rectangle at the same time, right? And so that, I guess that's what's kind of causing our problem is we must have something that doesn't quite work there. What I'm going to do is I'm going to go ahead and like freeze these guys so that they can't advance anymore, right? I'm just going to freeze them. So now they should be unable to continue. So I'll be able to look at just this one thread. And I'm going to see what happens if I let each thread individually do its thing. So when we come in here, I'm going to get, it was supposed to. Who unfroze you? Oh, the main thread came in. Freeze. There we go. All right, try it one more time. So we come in here, we're going to write event index 2764. And we're looking at that here, 2764. So here we go. I'm going to take a look at what that writes out to. Here it is. It's writing in the begin block for thread 4652. That's all good. Writes it all in there. Here it goes. And then we get down to the end block. All the other threads are frozen. So now we should see something right here, a 4652. The end for that guy, right? And I guess there was an interceding guy who snuck in there as well. That's probably the begin block for the other guy, for the one that, for the main thread that stuck in there. So there's the 2, there's the 1, there's the 2, right? So that's good. Okay, so now let's unfreeze one more thread. This guy was going, so I'll go ahead and freeze you, and I'll unfreeze you. Thaw. And you can see what I'm doing here. I'm just telling the threads which thread can do what when. So it kind of has this sort of ability for me to watch more carefully what's actually happening. So here we go. I'm going to start writing to it. You can see it writing in here. There's the start, 5884. Writes everything in as I would expect. Gets down to the end block. Should write it out here, and it does, as a 2. So it kind of looks to me, again, I don't know, it looks a lot like some kind of a race condition. Because when we force these guys to serialize, meaning, you know, when we prevent them from being able to hit the debug array at the same time, I'm not seeing the kind of ridiculousness I was seeing before, where you were getting all of these opens and closes with the wrong thread IDs. So that seems suspicious, but at the same time, I don't know. Like, I don't have any idea why that would be happening. I don't see where we would be having the race condition there. So let's freeze this guy again. I'll thaw another one out. So there's thread 912 coming through, right? And there's thread 912 closing. Again, perfectly paired. Exactly what we would have thought. So it looks very suspicious, right? You know, it's not a smoking gun, but it looks very suspicious. Because why is it suddenly behaving so much better when we freeze the threads? There's got to be something, it would seem, in this that is incorrect. That's not, it's not doing the right thing, right? That's something that it's allowing it to misbehave. And so if I look here, you know, these are all values that should not be changing. The only value that we really use is this one. We get that debug event in here, right? So we've got get thread ID. Get thread ID, as far as I know, is not doing anything weird. Maybe there's some reason why get thread ID is itself not thread safe. Like, I don't know if read GS dword somehow doesn't work properly under, but I mean, it shouldn't have any thread dependence whatsoever. I mean, it should be, that should not really have any bearing on anything, I wouldn't think. Although, you know, maybe there's some reason why that's actually not quite safe. Because if the get thread ID was coming back bogus, then that would be something. I suppose the other thing we don't really know, we could do something where with get thread ID, we're getting back a U32, obviously, for get thread ID. We should probably try to determine, well, we're already doing that. We're already verifying. I guess that's not true. We don't verify that it actually fits in a U16, right? So the other thing we could do is we could do this. Just to make sure that we're not truncating it in some bad way. But I would not expect that to be true. But I'll just double check. Again, at this point, I'm, you know, sort of paranoid about it, right? Because I don't really know. If I don't have a good idea of who the culprit is, then I have to start to suspect every last little thing. So that's fine. So I don't know. I'd say this is probably the hardest debugging problem we've seen on Handmade Hero so far. That doesn't necessarily mean it's the hardest bug, but it's definitely the one that's caused me the most perplexing. Which usually has to do with you not guessing, not being able to guess in the right direction of what the problem is. So, atomic add U64 is presumably not at fault here because we would assume that we would have seen that in some other way, right? When we have, let's see here, we have been using those atomics, you know, the Windows atomics, pretty much for everything we've done, and we haven't seen any problems with them. So if there was a problem with the way that we were calling them, we would have expected, I would think, to see it in the renderer somewhere or whatever. Now, granted, we're never calling it as heavily as we're calling it here. That is true. So there is a little bit of that, I suppose. But even so, you know, it's doing an interlock exchange at 64-bit. Is it conceivable that it's not aligned? Somehow? That it like straddles a cache line? Or something like this? Such that it wouldn't be, that seems just really like I'm grasping at straws personally, what it kind of seems like. But I mean, all right, you know, let's make sure, just because why not? So let's make sure that the address of that guy and the bottom 64 bits, right? So I want to, I guess what I'm saying is I want to make sure that this guy isn't in some kind of a weird alignment, so that it's aligned on every 64. So I want to make sure that the excuse me, the bottom 6 bits, well, I guess 8. So the bottom 3 bits should all be 0. So I want, you know, something like, you know, I want to make sure that I don't have, if I was to cast this to a U64, whatever the address is of this thing, right? I want to make sure that, you know, that would be aligned to every 2 bytes. That would be aligned to every 4 bytes. And I want this aligned to every every 8, right? My brain's kind of fried here. A little slow. So yeah, I'm just going to see what that does. Right. Yeah. So sorry, that's not quite right. Yeah, my brain is totally fried. Sorry, I'm too busy thinking about the bug and I'm not actually thinking about what I'm trying to be explaining here. So that would be if that equals 0, then your low bit, that tells you every other byte, right? That tells me the next bit over, but I need both. I need to know that the low bit and the next bit up is not set, right? So that would be for every 4. And so then, you know, I wrote it right the first time, but then I was trying to explain it. I kind of said it wrong and typed it wrong. And so that has all 3 bottom bits set. So now we know that we're by 2s. We're not by 2s. We're not by 4s, and we're not, you know, we've got to be by 8s, right? So that we're aligned on a 64-bit or 8-byte boundary. So I'm just going to go ahead and run that. That's a little bit odd. Oh, well, that's all right. I guess sometimes the block name in the source is 0. So we should allow our string routine to handle that. We can just say something like b32 result is false if a and b, like that. So now you can pass in null pointers if you want, and it'll just tell you. Although I suppose we could also do something like this. You know? Oops. So essentially, like, if they were both null, it would be okay. Because technically, if you say strings are equal 0, 0, that probably should be true, because they are same string. So that seems like a fair thing to do. All right, so let's run that. Yeah, so that's all aligned properly, so there's nothing weird going on there. So our atomicness should be fine. Yeah, and there's nothing peculiar there. I don't know. This is a stumper. I could just, if you think it would be fun, I could end the stream and see if people want to try debugging it, see if they can figure it out. We've pretty clearly stated what the problem is, right? So you should have a very good idea of exactly what you're looking for. But why it is happening is anyone's guess. We pretty much don't have any idea. We pretty much don't know, right? So yeah, I think I'm going to end it. We're going to sleep on it, and we'll see. And we'll think about tomorrow how we want to approach debugging it, because it looks like I don't have any good ideas for it. And I think we may have to, like, what I am leaning towards doing is trying to pare this down to the smallest possible repro case so that I can debug it more in isolation rather than having to do it kind of with a giant set of debug events in the running program, right? So I think that's what I'll do. Maybe someone already knows what it is, but I'm assuming that without doing the debugging themselves, they might not be able to. So let's go ahead and go to the Q&A. And I will leave debugging that as an exercise for the reader overnight, if anyone can find it and see. The Sizek, try running without timing draw rectangle. Oh, sure. If you want to see, if you just want to see if it's like only this one routine, which is a perfectly reasonable thing to want to do, just to get more information. Like, is there something weird about draw rectangle specifically? And it does not look like it, right? It looks like it's just happens eventually. Regardless of what we time. The other thing is, I suppose, you know, there's the timing that's in render group is the timing that's going to be multi-threaded. So, you know, what we could do too is say here, like, inside render group, we could replace timed function with ignored timed function, like so. And then up here, we'd just do pound find ignored time function. And that would take out all of them. And similarly, inside optimized, we do the same thing. And that would give you like one that presumably wasn't really doing any heavy multi-threaded use. And, you know, it does sort of reinforce the notion that the code was working properly when it does not have, excuse me, multi-thread contention there. And so, you know, yet further evidence that it suggests that something's wrong, but still doesn't really tell us what the smoking gun is, you know. So still a puzzler, in my opinion. The MSDN documentation for read.js keyword states these intrinsics are only available in kernel mode, and the routines are only available as intrinsics. If this is the case, how were you able to use read.js keyword to read out of the thread ID? I'm not really sure what the difference between kernel mode and user mode is. So I'm pretty sure that is a bogus claim on the MSDN documentation. And the reason that I say that is because we took a look at how get current thread ID worked. We looked at this assembly, and it issued a direct read to the GS segment. So clearly you don't need to be in kernel mode to do it, because Microsoft's own code does it not in kernel mode. So I don't know where that notion came from, but it doesn't seem to be at all grounded in reality as far as I can tell. So all we're doing right now is exactly the same code that would have happened with get current thread ID as far as I know. You said that it seems to work normally for a little while, then stops working when it's under stress. Maybe let the threads run wild for a little while, then freeze them, or is this not possible with the debugger? Well, that is what we did. Or, I mean, yeah, I mean, we can definitely do that. So, in order to do that, let's go ahead and switch this back to broken mode. Oh, well, you know what, though? Let's not quite do that. Let's just see if turning on the just draw rectangle is sufficient to reproduce the problem. That I would like to know. Really? Yeah, see, we got some weird bugs in here. Like, what is going on there? How could turning off stuff end up with more regions? You know? It's very strange. I guess it's probably because there's no parent. That's probably why. There's no parent to draw rectangle. So you're just going to see a ton of draw rectangle calls, right? Excuse me. So yeah, I mean, that I guess isn't really that surprising, but still. Man, I guess there's just a lot of draw rectangle calls. This is going to be like an infinity of draw rectangle calls, right? Because it's every time we call draw rectangle, it would add another region per frame. Does that make sense? Because the regions themselves are draw rectangle calls. So it's just this kind of infinite feedback loop sort of a thing. It's not an infinite feedback loop, but it's a bad situation. So yeah, I'm not sure how we would really get by that, because there's going to be a ton of them. Right? Because as soon as it's just going to keep adding more and more and more, more and more and more of them. Let's see here. How many debug events are there? Current frame. Yeah, it's that first one. That first frame has way more debug events than everybody else, which is also a little bit odd. I don't know why exactly that would be. Maybe because it has to do a lot of initialization of stuff, which is causing more debug events. But it is a little weird, right? That's sort of a separate issue there. Like, it's a bit odd. Is it possible that the array index part somehow got swapped out during the begin and end records? Even if it did, that's fine. We don't count on that not happening. Did you create your colors to be easy on the eyes? If not, how did they come to be? Are you talking about the grid ones, or? Didn't you remove the end block call? No, it's still there because it's sort of implicit. If you take a look, the time function, it includes, it automatically does the begin and end, right? That's its job. It uses the constructor-destructor pair trick to make sure there's one at the beginning and the end. So, you know. But yeah, I wanted to do that. I guess what I can do, so here's the way I can fix this problem, because I don't want to have to deal with this. The way I can fix this problem is in the render group, I can just put one more of these guys back in, like the top level guy. That way it won't add a region for every rectangle call. So if we did that, it'd just be in here. So now we wouldn't be pushing those regions on, and then it'd be fine, I should think. Or not. All right, so this is kind of interesting as well. Let's take a look at what happens here, because I'm interested to know why that's happening. Source. So draw rectangles should not be happening without an enclosed person, right? Who is calling draw rectangle that's not underneath one of these two guys? Like, where can draw rectangle be called? So it does get called directly, just straight out of the gate. So there is one place there. Well, although that's if zeroed out, though. So that wouldn't count. Draw rectangle quickly doesn't count. Draw rectangle, there's our time function. Draw rectangle slowly does not count. Draw rectangle in the render group. This is inside render group to output. So render group to output. Oops. Render group to output. Is pretty much only called inside the guys that I just said, right? There's render group to output. So I guess not. So do tiled render work doesn't actually count because it isn't under here, right? All right. We'll see. Okay. So now we don't have that problem once those guys are sort of, you know, stuck under there. Now we are properly seeing the render kickoffs and everything else, it looks like. So having those draw rectangle calls kind of wild, that's kind of interesting. I'm going to go ahead and make ignored timed function be timed function again. So I'm going to turn all these guys back on, and I'm going to see what happens. So it still has a problem if you turn everybody on, if that makes sense. All right, let's try one of these at a time. So now with everybody on except the optimized code, right? If we're just discounting the optimized code, we are not hitting the case. So again, you get one more piece of data there. Let's see. Elvin, if the debug code is slower than the actual runtime of the game, how can we rely on the debug systems to give us accurate timing of how long things are taking in the game, since they naturally take more time in debug mode? Well, again, there's a lot of stuff that we'll kind of be looking at to what degree, to how much stuff we can do and still reasonably get good timings. Remember, it doesn't matter how slow the game runs. It only matters how slow the part that actually interferes with the game's running takes. So the overall time when we actually draw it separately, that part is not so critical. Like, we don't care if that slows things down because that doesn't really affect the code that it's timing. It's only the part that does the actual timing that can't be slow or that can't interfere too much. If that makes sense. So you can kind of see too, like, this is already, I believe, showing us what's happening in the game pretty clearly. I also, you know what, why is it, I want to move it down a little bit further as well. So let's go ahead and do this here. So let's just say that at y here, I'm going to give it another 300. Just so I can see a little more clearly. But you can kind of see, right? You can see what's going on here, I believe, if you look at what these actual frame display things kind of look like. You can see that you've got, you know, this is that first kickoff. This this is rendering the game. This sort of first batch here. Those are the threads that actually render the game. And this batch up here are presumably the threads that render the debug output, right? Do you know what I mean? So it's kind of interesting to see that. And the other thing I could do is when we render these, we could render less of them so that they fit on the screen properly. Again, we'll kind of get to all this stuff a little bit later, but just for sake of the argument. So, if we did something like, well, we've got, n frames, we know that the most recent frames are the last frames. So if we did something like this, we could do something like, okay, give me the frame that's the frame count minus the frame index, or like that. And then here what we do is we'd say, well, I really just want to go to like the 10th one or whatever, or something like this. So it'd be something like U32 max frame equals debug frame count if max frame is greater than 10, max frame equals 10. Just throwing that out there for now. And that way, presumably we would have less of these. Well, although that's still drawing more than 10. What did I do wrong there? Oh, didn't use it. Max frame. So at least then, yeah, we kind of have a little bit. So this is the most recent frame here. And you can kind of see now a little more sane. It's not spending so much time drawing rectangles and stuff like this, right? But you can kind of see here, now we have, again, a better sort of picture of what's going on. But even just before we've even debugged this system, you can now see a really clear picture, even just from this really, really lousy visualization. Since we haven't spent any time actually with the viz stuff, you can already see a really good picture of kind of what's happening in the game. Here's the main thread, right? And you can see it's broken up into like the game update is this large solid part. Here's the part where it's waiting for the frames to change. Here's the beginning part where it was like processing input and stuff. And then here you can see the threads getting kicked off to do the rendering. And then here you can see the threads getting kicked off to do the rendering a second time for the debug overlay. So you can, again, people were sort of saying, why do we spend time on the debug code? It takes too long. I mean, the stuff we're going to find out and be able to see from just a few weeks of work. And don't forget, if you weren't breaking this up into chunks that had to be an hour a night, this is not very much work. You're talking about like full-time 1 week, maybe 2 weeks of full-time work at most to write a decent debug system. The stuff that you end up seeing in it just pay off so huge. Already, this kind of validates what I think is happening in the code. And it gives me a much, as soon as we're going to be able to drill down in there a little bit more, we're going to learn a lot of stuff we probably didn't know. And it's also kind of interesting to see how much time is spent prior to kicking off those threads. It's actually pretty significant, more than I would have thought there. So I feel like that's, yeah, I feel like it's a really good idea to spend time on this kind of code because I feel like you learn a lot of things that you wouldn't know otherwise. If I remember correctly from the other day, you discard events if buffers are full. Are you sure all buffers are big enough? Well, actually, that wouldn't cause the problem, though. Because the problem that we're seeing is that we're getting to end events that don't have corresponding begin events. If we were throwing out events when the buffers got full, we would never see the end events either. So throwing out events when the buffer's full is actually fine. But no, I don't think we're having that because we have an assertion in there, actually. At the moment, we actually have assertions in there like this, So yeah. I'd also be interested to see, just for a moment, I'd be interested to see if we go into our build.bat, what the difference is if I was to run release mode. So it's interesting, you can see that there's just like a lot less time spent there, right? Not sure what those were some interesting spikes there. Like, I don't know what those spikes were from. That'd be something that, again, we'd want to go ahead and investigate. Oh, you know what? We missed, that's missing the frame. You can see that it misses the frame turnover, it looks like. So that'll be interesting to investigate as well. Again, really pretty interesting stuff. The size could it be threads running across a frame boundary? I mean, yeah, I mean, obviously it could, I just don't know. I mean, since I don't know what it is, I don't know what it isn't, right? But, you know, this code doesn't care if that happened. It really doesn't care. Because let's say that the begin events had fallen off the event arrays. So, you know, they happened on the last frame and the last frame fell out. So we're starting on the furthest back frame, we're starting to process it. We don't have any begin events. We see end events, we just throw them away. Right? They wouldn't be causing a problem. They wouldn't be causing the problem we were seeing, which is that the open block array is filled with people who never got closed. From then on, we're processing everybody on all frames. So it doesn't matter if a person crosses a frame boundary, we should still pop them off properly, right? We don't reset the frame stack when this doesn't reset the frame. I'm sorry, this doesn't reset the thread open block stack. So it shouldn't matter if they cross. So, yeah. All right, I think that's about it. We're gonna leave that one be. Well, you know what? I'm gonna restore it to its non-working state because I don't want to leave it in a state that's actually working. So I want to put it back into a state where it is broken so that we can work on it tomorrow. So that was the broken version, yeah? What has happened? Oh, no, that's correct, because we're only seeing the last 10 frames. Yeah. So, yeah. So we're back in the broken state here. So I'm going to leave it like that because I want it broken when we start looking at it tomorrow. So that's good. Let me go ahead and close down the stream. Don't know why it says nothing scheduled. There we go. That's what it should say. Okay. Thank you everyone for joining me for another episode of Handmade Hero. This is a bit of a stumper. This is the first time I think we've had one on Handmade Hero. So I feel like this is a kind of a tricky problem to debug. And it'll be interesting to see what we do tomorrow to try and track it down. Yeah. We're gonna have to give it some serious thought because there doesn't seem to be anything particularly obvious to try. If you've got ideas, you can always try hunting down the bug yourself, see if you can find it. This is a tricky one, so if you're looking for some debugging practice, I would say it's probably a good one to try. because it was not something that was immediately obvious to me. So I don't think it would be immediately obvious. And it might give you a good chance to try and play around with hunting down something that may even be a multi-threading bug, which is a particularly tough type of bug to find trivially as well. So anyway, if you want to check that out, you can always do that if you are someone who's pre-ordered the game. Again, it comes with the source code, so you can download the source code. I'll upload it now, and you can download the latest version and then see if you can find it. If you do, I don't know if you want to do spoiler warnings or not. You can post it on the forums and see. Maybe we can see who gets it first. I assume you guys could easily beat me to it if you started now. My voice is about to go, so I'll just sign off for now and say thanks everyone for joining me. I'll be back here tomorrow. I think it's a late stream tomorrow, so it'll actually be 8 p.m. Pacific Daylight Time tomorrow, when I'll pick back up the bug hunt and see if I can't find out what's wrong with that guy. Until then, have fun programming, and I will see you guys on the internet. Take it easy, everyone.